Hello, everybody. Welcome to Tech Tablet with me, Abdinisa Begum. And as you all know, we are going through a series of sessions on Tableau as we plan to complete the complete Tableau course, the full Tableau course. So that is why what we have been doing is for those who are new, for those who are listening to me for the first time or watching this video or have visited this channel for the first time, we are trying to complete a full Tableau course. And in that, we have been covering different plots and graphs because that's how we would be creating a visualization, isn't it? So that visualization or that report that you are going to create and present to your clients or your managers or even your students, right? So that you can prepare using Tableau. And before that, much before that, you need to understand the use of different types of plots and graphs. And I understand most of us do not even know what is a box plot or a whisker plot, as you like to call it. So that is what we are going to discuss about today. Like I said, the agenda is really simple. We're going to understand what is a box plot, and afterwards, we're going to create a box plot in Tableau using our same Superstore US dataset. Now, before that, let's just try to understand, or even before that, let me just introduce myself. My name is Avitunisa Begum. I am a technical trainer, and as you all know, I have also mentioned before that I give trainings on different programming languages, R and Python, and specifically for data science, and Tableau for data visualization. Yeah, so that's about me. Now let's move ahead and now coming towards box plot. Now the picture you're seeing here is a box plot. And how do you interpret it? This is exactly how the box plot would come when you plot it, right? So you need to understand what is it, what are the different labels in it, what are outliers, minimum, median, maximum, interquartile range. You need to understand all of these before going ahead, right? So let's just try to understand. So this box plot, it's a standardized way of displaying the distribution of data. And there is a principle to it that's called as a that's basically a 5 number summary. So the first one being the minimum, then we have the first quartile, then we have the second quartile. Oh, sorry. Then we have the third quartile. I'm sorry. Then we have the median. Then we have maximum. So this is the 5 number summary. Or rather, you can just interchange the numbers here. 3 is for median and 4 is for third quartile. So this is how it goes. Minimum, first quartile, median, third quartile, maximum. That's how it will be divided in. Now what does all these tell you? They tell you about the outlier. Also, they tell you about the outliers. You know what are outliers, right? I have also explained it before, but no problem, I can still explain it to you. So suppose there are students, there is a class of some 10 students. Okay, just an example. And all of the students get marks around 35, 36, 37, 38, 39, 40. Okay, there are some 6 students then 41, 42, okay, and 43. So these are some 9 students who have got these normal marks. Suddenly there's a student who scores 92 marks. So these are all out of 100. Okay. So suddenly a student scores 92 marks. Now that student is your outlier. Even in a cricket team or during a cricket match, all the players they score around 30, 40, 50, but suddenly there's a player who scores a double century. Now that player is your outlier. And how does these outlier points looks like? So if this is your graph and these are different plots, sorry, your data points. Suddenly there's a point somewhere over here or even somewhere over here. So this is not a bit of outlier, but outlier has to be really far away where you cannot, actually work with the data on. Okay, so this is your outlier, or probably there's a point here, and that will be your outlier. So those outliers, instead of scatter plot, you can also see it in box plots as well. Scatter plots is actually a very good way to find outliers, but then we have box plots too now. Now, what else does so now I hope you have understood the outliers. So first thing, like I said, it is telling us what are our outliers. What else does this graph tell us about? It tells us that if our data is symmetrical, we can also know how tightly our data is grouped, and we can also know if the data is skewed to one side, right? So that's all what this box plot is telling us about. So first one, 5 number summary. Second one, it shows us the outliers. Third one, it's showing us if our data is symmetrical or grouped or skewed. How is it? So yes, I hope now you have understood why are we even doing this. But do you have some other questions also when looking at it? Definitely. I had questions like what this could be. What is this box plot? And we also would want to understand the anatomy of box plot and how do you interpret box plots in Tableau is what else that we are going to do now. So what is box plot exactly is, again, if you want to term it, for some distributions or for data sets, we'll find that we need some more information than the measures of central tendency, right? Mean, median, mode are our measures of central tendency. Yes, we have a median here, but we don't have mean and mode. So we need some more information like what is the minimum, percentiles, interquartile range, maximum outliers. So there are all these that we will have to know. That is when we need to have information on the variability and dispersion of the data. That is what a box plot can do for you. It gives us a good indication of how the values in the data are spread throughout. Now although box plots, they seem primitive in comparison to a histogram or even a density plot. You know what a density plot is, right? So they have the advantage of taking up less space, and they are useful for comparing distributions between many groups or databases. Now let us talk about these parts that I told you. So first we'll talk about the median. So this median, so you can see here quarter one, quarter three. We don't see a quarter two. This median is actually our quarter three. So if first one is 25th percentile, third one is 75th percentile, then definitely this is the 50th percentile. That is median. So as you all know, median is the middle value of our data set. Then you have your first quartile. Now what is first quartile? Again, Q1, 25th percentile. And this is the middle number between the smallest number and the median of the data set. Okay, smallest number which is not minimum. Okay, somewhere are after minimum. From there to median, that is our quartile, first quartile. Then we have the third quartile. Now, what is third quartile again? Would you like to take a guess? Now, till I write, you might as well want to comment here, or you can just think of an answer for yourself. What could be this third quartile? We know it's Q3, we know it's at 75th percentile. But what else? Similar to minimum, you can say that it's the middle value between the median and the maximum highest point, but not the maximum. Okay, this is your maximum. This line is your minimum. So when we are talking about median here, or the sorry, Q1 or Q3, this is how we do it. Then we have an interquartile range. You can see this here, interquartile range. It's 25th to 75th percentile. The range from 25th to 75th percentile, this is our IQR. So from Q1 to Q3, we have it. That is our interquartile range. Now these lines you can see here, these are called as whiskers. That is the reason why we call them box or a whisker plot. And these green ones, as we all know, these are outliers. Now suppose, so you can see, you might as well want to write these down. This is the formula for the minimum. This is for the maximum. So as of now, we may be not able to understand, an outlier, minimum or maximum and all. So here is what we are going to try to understand how this works now. Okay, now let's just create. Okay, sorry for this. Now we'll try to create a. Okay, what I'm trying to do here is I'm trying to create a normal distribution graph. I'm sure you all have seen it. Pardon me if the figure looks disfigured. So, okay, but just this is for your understanding. So let's make it as big as our box plot. So this is how the same distribution that we are able to see using the normal distribution curve, we are going to see here with box plot. Okay, so what is in here in between these values? Okay, so the interquartile range is this. So if you try to compare normal distribution curve with box plot, the probability density function for a normal distribution, so can be compared in both of them. Now we can see that the statistical distribution is more commonplace than looking at a box plot, right? So in normal distribution curve, if you're not able to understand it better, then in the box plot you can be able to easily understand it, right? I really hope now when you are trying to compare it with a normal distribution curve, you are easily able to understand what is this, what is a box plot basically, right? Now, oh, you might be thinking that, where can we use these box plots? So one example that I mean, the most important usage of this plot is basically to understand how distributed is our data, right? But still, if you want to understand it better, what this box plot does, it provides a visual summary of what? Of the data that we have. So because of that, the researchers, they are enabled to quickly identify the mean values, the dispersion of the data set, or even the signs of skewness. I'll explain you what skewness is. I'm sure most of you know it, but for those who do not know, I'll explain that. But for now, let's try to understand the different usage. Now, box plots, they can also show us the average score of a data set. Okay, so first, it's a visual summary of the data. Next, it can tell you the average score of the data. And then it is also used, like I told you, to understand the skewness of the data. Now, the shape of this box plot will show if a statistical data is normally distributed or skewed. So, I'll draw three box plots here. Right? You are able to see three box plots here. And now I hope you are able to understand what is skewness. Are you? Let me tell you, this is not what skewness is. How do you understand skewness is depending upon the median that you have. So if your median is in between, exactly that is your normal distribution. If you see it towards here, that is positive skewness. If you see it towards here, this is negative skewness. So this is normal distribution. This is positive skewness and this is negative skewness. So median is in the middle of the box, then the whiskers about same on both sides of the box, then the distribution is symmetric. When the median is closer to the bottom of the box and if the whisker is shorter on the lower end of the box, then the distribution is positively skewed. If you're not able to understand it like this, you might as well draw it like this to understand it better, right? So this is our positive skewness, and this is our negative skewness. This is our normal distribution. Like I told you, median is closer to the top of the box and the whisker is on the upper end of the box, then this is negatively skewed. Now, if you have understood the skewness and if you have understood how the symmetry works, then let's understand the third use, the next use of box plot, that is dispersion of the data. It also tells you how the data is dispersed throughout. And they are also, like I told you, the most important one is showing outliers. They show you how the outliers are or there are any outliers at all. Now there, when you are drawing, when you are actually creating box plot, there is not just one box plot that occurs, there are a lot of them. Okay, so like I told you, I showed you three box plots here, right? So when you create those box plots, you'll have to compare them. So they are useful. Box plot is actually a very useful way to visualize differences among different samples or groups. So they manage to provide a lot of significance information, and that would include medians, ranges, and outliers. So how do you work on them? First, you would be comparing the medians of the box. So you will compare the respective medians, and if the median line of a box plot lies outside of the box of a comparison box plot, then there is likely to be difference between the groups. Now, what do I mean when I'm saying that? This is my box plot, plus I have another box plot as well. Now, can you see this? It's lying outside this box plot. Value of the median of one box plot lies outside of the comparison box plot. Then there is definitely a difference between these two groups. That is how you can actually compare. Now, that is one thing comparing with the medians. You can also compare with the interquartile range. So, to examine how the data is dispersed between each sample. So, the longer the box, the more dispersed is the data, right? So, that is how you can understand how long the box is. So, if the box is longer, one of the boxes is really long, and these are smaller ones, and then suddenly we have a bigger one. So, that's how you can understand how dispersed this data is. Then the next step would be looking for outliers, and outliers are clearly visible here. We can also understand the skewness. I hope you will remember how the skewness goes. So when we are talking about a normal distribution curve, it either goes this side, it either is normally distributed, or it goes completely to the left side, right? So what do we call it? We call it left skewed, right skewed, and normally distributed or symmetric. Same is the case with our box plot, right? It's just the same. Okay, so I hope you have understood the uses, you have understood how they are divided, and you have understood the steps in creating this box plot or even interpreting this box plots. Or if you want to compare, how do you compare these box plots, right? Now let's just go to Tableau Public and try creating the box plot. And while I am creating this, meanwhile, if you have any doubts in the explanation of the box plot or you think if there is anything else that I might add here, you can just mention it in the comment section and I will reply to you over there. And if it's something really important that I missed, I would also pin your comment up there so that others can be, will be able to see and comprehend over it. Right? So this is my Tableau Public, and I'm sure all of you know how to connect the data set. But for those of you who do not know, let me just start from the beginning. You can just click on the type of file you are using for creating your visualization, and you will have all the data sets there. So whatever data set you are trying to use, just select that one. So here I am using a Superstore US data set, right? So this is where I can see my data set and I can choose the sheet I want to use from my data set. Now in this, what I'd be using the orders only. Now I can go to the worksheet where I want to start working. Now these are my dimensions and measures. These are my pills where I use the columns and rows. I would select the dimension or measure that I'm going to use in these columns and rows. So first I would be taking a measure. So what is the measure that I'm taking? I'll be taking discount and I'll be putting it in the rows. Then I would be taking the customer segment that will be in my dimensions, right? Let me also take, or let me create this box plot now. But I think I will need to add a region or something else as well. And here I'll add a region as well. So you can see based on the products, types of segments, and also based on the locations, these are divided. Now, what do we have here? We have our bar charts. So first, let's just take it back. Let me just convert it into a box plot first so that you can understand it much better. Can you see here? This is open now. We can create actually a box plot. So you can see here, right? They are definitely, so these lines, if they are above these, that's how you compare it if you remember. But then these are completely different. We need to just take the measure. You can change the measures if they are aggregate, right? So now you can completely understand and you can see the outliers here, right? This is an outlier. This is how you can see, this is how spread is our data, right? And if how do you compare? None of these values or these medians, they are not above the other. So there is not a lot to do here. Now you can change colors if you want. Okay, you might just want to take region and put it into color, right? So you can change the color of these outliers and all. Right? So this is how you basically create your box plot in Tableau. Creating graphs in Tableau is really easy. The most important thing is you need to understand how do you interpret your visualization. You need to understand why are you using that visualization at all, right? That is the most important. So try to comprehend over it before you start, creating these graphs. Like I told you, W is only about dragging and dropping. Create as many reports as you want, but you need to understand. So what I would suggest you is whenever you are creating a box plot, whenever you are, practicing on Tableau, try to interpret it in a good way because yes, you can show these visualizations and reports directly, but then depends upon how you are explaining. What do you want to interpret out of them? What do you want your clients to interpret out of these graphs? So see, there are different people who look at different things. I might be looking at a median here and you might be looking at the outlier here. So different people interpret it in different way. So you have to be able to explain them what exactly are you trying to show here. I really hope you guys are able to understand me. But if there is anything you are not able to, do mention it in the comment section, and I'll be really happy to help you over there. So thank you very much, everyone, for being with me throughout this session. I really hope this session is helpful for you. You understood what is a box plot and how do you create a box plot using Tableau. Thank you very much for being with me throughout. Have a great day and happy learning.